right? Part A. So basically, it says, oh, where's my? It says the following. That is, you have x1 to xn iid from a uniform distribution on the interval 0 to theta, and we are testing theta equal to theta 1 versus this, where theta 2 is greater than theta 1. Did you say you can do part 1 or no?
Part A, yeah.
You said part A. Sorry.
Yeah.
Okay. All right. Part 1 is to find the most powerful test. Right. Remember, whenever you see these two words together, when most powerful, what it means is that a test obtained using the NP lemma or the Neyman-Pearson lemma is always most powerful. So when the question says find the most powerful test, you must use the NP lemma. All right. I said this several times before, guys. So the answer is as follows. The first thing you must say is the following. That is, by NP lemma, we reject H0 if the likelihood at theta 1 divided by the likelihood at theta 2 is less than a constant C. Now, do you guys know where this comes from? This comes from the last page on the lecture notes. If you look at the printed lecture notes, guys, this is the last page. Okay. Now the likelihood at theta 1 for the sample from the uniform is right. Do you see where these guys come from? This is the product of the density function of the uniform, which is 1 over theta 1, and you have to multiply it by the indicator function that each xi is between 0 and theta 1, and the same thing at the bottom, right? Now let me ask you, now if you multiply the indicator function, what would you get, guys? I mean, this is a rule you must remember for the final exam. If you multiply this guy here, I from 1 to n, you will get you must remember this formula. Right? Do you see where this comes from, guys? This, if you look in the the formula sheet I gave you for the exam, you will see how I got from this line to this line. Guys, have you looked at the formula sheet for the exam? It's on my website. Yeah, you see how I got from this line to this line. Yeah. So now you see that this guy cancels with this guy, right? So what you have is all right, what you have is this, guys. Okay. Yeah, are you with me, guys? Right. Now, if you look at the left hand side, what you have in the left hand side is a function, because theta 1 is a fixed number, theta 2 is a fixed number, theta 1 is a fixed number, theta 2 is a fixed number. So what you have here is a function of the maximum of xi, because the only thing that is not fixed here, guys, is the max of xi, and therefore this guy here is a function of the max of xi, which I call g. G is a function of max of xi. So g of this is equal to this, right? Now the next thing I'm going to do, hopefully you can see this, guys. The next thing I'm going to do is I'm going to draw a graph. I'm going to draw a graph on the y-axis of the graph. I'm going to have g. On the x-axis, I'm going to have max of xi. Yeah. Now what I'm going to, so basically I'm graphing this function versus max of xi, right? Now suppose your theta 1 is here. Suppose this is theta 1, and suppose this is theta 2. Now how do you think the graph will look like? Because theta 1 must be less than theta 2, right? So suppose you have it like this. Now over here, now let's take a point at a time, right? Suppose your max of xi is here, right? Suppose your max of xi is somewhere below this theta 1, right? Now so in this case, this guy here, oh sorry, can you see this? No. In this case, this guy here will be equal to what? Theta 2 power n times what will this will be equal to? Talk to me, guys. If your max of xi is here, what would this be equal to? Is it, remember, an indicator function can only take two values, 0 or 1, right? If your max of xi is over here, this will be equal to 1, right? It's equal to 1, and this will be equal to 1 too. So 1 divided by 1 is 1. So what you have is, up to this point, this value is equal to, yeah. Now suppose your max of xi is between these two, that is between theta 1 and theta 2, right? In that case, this will be equal to 0, but this will be 1. So 0 divided by anything is 0, right? So the graph will be this over here. The graph will be this in this region. It will be 0 over here. Now if you pass theta 2, suppose your max of xi is here. In this case, what you have is what you have is this will be 0 and this too will be 0. So 0 divided by 0 is undefined. So basically over this region, right? So the graph, so you see what I've done, guys. So what I have done is to graph this here as a function of max of xi, and what you see here is a step function, a decreasing step function, right? Yes. So let's go back to what we had earlier. The question we had was that we had this, right? Now if I multiply g by g inverse, now what will happen to this sign? Will it remain less than or will it be greater than? Now we know that g is a decreasing function. If you're taking you're multiplying by the inverse both sides of a decreasing function, the less than will become greater than, right? So what you have is max of xi is greater than g inverse of c, which you can call it a constant k if you like. So that proves part 1. Is that clear, guys? So this is part 1 of question 6, 2012-13 exam paper. Right. You alright, sir? You look lost. Are you okay? Yes. I mean, when you take the inverse function of a decreasing function, you have to change the sign around. That's why when I move from this line to this line, the less than become greater than, right? But if g is an increasing function, then you don't need to change the sign, right? So, but in this case, as you can see from the graph, g is a decreasing function, right? So when you take the inverse function, both sides, you need to change the sign around. I thought you might know this already. Anyway, if you don't know this, just note it down. Okay. All right. Do you want me to do the other parts also? Are you okay with the first part? Or?
Yeah, I think this should be okay.
You should be okay.
Yeah.
Okay. All right. Other questions, guys? I hope this is clear to you. If not, ask me, guys. There was some other guy who asked me a question over the email. I can't remember. Was it one of you again? You asked me. You sent me an email last night. Somebody sent me an email last night asking me the question. Who was that? I can't remember who it was. Did somebody send me an email last night? No. Was it you? No. Okay. Anyway, any other questions you want me to do, guys? How about you guys? Do you have any questions? What about you guys? Do you have questions you want me to do? Are you guys okay?
Yeah, sigma, you just need to take the square root of this. So the ML equal sigma will be just the square root of this. So you need to take the square root. That's it. Yeah. Write down. Yeah, I could have, but I mean, I thought it's simpler to write down the sigma hat square instead of sigma. You see, otherwise I need to put a square root. Yeah, I know what you're saying, but I mean, the exam is okay. It does because sigma hat square is just a one-to-one function of sigma hat. So it doesn't matter whether you give sigma hat or sigma hat square. Yeah, okay. Yeah, that's what I was saying yesterday, because I use a different notation for percentiles in my notes. When I, like, if this is the, I mean, this point here is exactly 0.05. So this area is 5%. That's what I mean. I know it's different from other lecturers. I use this notation to mean this point here. Yeah, in the exam also it will be like this. No, I prefer if you use this one. I prefer if you use this one, not. In my notes? No, yeah, but I use a different notation. I use 1 minus q, not q. I use 1 minus q. No, I use q here. Yeah, I use a different notation. It's different from. Yeah, you should follow me. Yeah. You guys are okay? Have any questions you want me to do? Not now. Guys, please ask me some questions, guys. I mean, trying to find my example booklet. Can't find it. Is there any problem from the examples booklet you want me to do? I'm trying to find it, but I can't find where it is. I had it yesterday. You guys know the examples booklet? Yeah, you have it, right? Is there any problem from there you like me to do? Yours for a second. I don't know why I left mine. Let me see. All right, let's do one of these problems, guys. I'll give this back to you just in a minute, okay? This is example. This is example
example 8 in the example booklet, you're told that U has a normal distribution with parameters 3 and 16. You listen, guys, please. And V has a chi-square distribution with parameter 9, and they are independently distributed. And the question is to find the probability that U minus 3 is less than 4. Right? Can you see this question, guys? This is AR. Thank you. Yeah. This is example 8 on the example booklet, guys. Right? Would you know how to do this? Had you tried this example before? No? Okay. Let me show you then. Now, so to find this probability, so we know that U is a normal variable with parameters 3 and 16 minus 3 less than 4.33 times the square root of a chi-squared variable with 9 degrees of freedom. Yes? Now let me ask you, what is this equal to? What is the normal variable minus 3 will be equal to? Huh? Come on, guys. Please. It's equal to normal with what parameter? The mean will be 0. The variance will be 16, right? Less than okay. Now, how do you get rid of the 16? In order to get rid of the 16, you need to divide by 4 and multiply by 4. Right? If you divide by 4, you get do you see what I've done? If you divide this by 4, you get the standard normal variable, right? So you have to multiply by 4 too. Right, now I'm going to take this 4 here to the right hand side, and I'm going to take this guy here to the left hand side. Right, so what you will get is the following. You get come on. Oh, this pen now stop writing all the time. Right. Right. This is what you get. Okay. Now, I'm going to do one more thing. You see why I'm doing this in a minute, because I will explain this in a minute, guys. You see, I have divided this guy here by 9 and multiplied by 3, so I haven't changed anything, right? Right, now this is the big question now. The question now is, guys, what do you know about this? What is the distribution of this? You should know this, guys. We did this in the class. Do you guys recall this? Yeah. No? Yes. Come on. You don't recall? I thought you guys had better memory then. You don't recall what that is? If you look at equation 77 in the lecture notes, right, you will see that this, what you have here, is the T distribution with 9 degrees of freedom. Remember this, guys. Let me show you where it is. It's this formula here, equation 77. Then we done this right in the class, right? So that's what I have used. So if you use equation 77, this is equal to a student's T random variable with degree of freedom equal to 9. Okay? And it's equal to 3. So that's it. So this is the answer, guys. If you have access to a computer, you can find the value of this numerically using, like, for example, R. I'm sure most of you know R, so you can work this out exactly what the value of this is. Yeah. So is that clear, guys? No. You alright, guys? Any other questions, guys, you like me to do from the example booklet or any other place? You guys okay? Do you have questions you want me to do? That was the last one. Okay, thank you. Any other example problems you'd like me to look at? Yeah, I just sent you because you asking me for that. Just try to write the work yeah. Try to as much as you can then I'll do it based on the state of the foundation. See how you can yeah, and also I'll do based on you may want to also go to PB class. Often PB class. That's the one here.
Guys, please, any other example problems you like me to do? Example booklet problems. You have any questions? Okay, let me see. Oh, sorry. Oh man. What about this one? Is it 42, right? 40. Yeah, let me. All right, I just want one. I can do just to waste my time. All right, let me try. I don't think you have done this, guys, but I will do this one. Example 42 from the booklet. Okay. So basically, you're given x1 to xn IID from from the beta distribution with parameters a1 and a2, and the question is to find the MLEs of a1 and a2. Do you guys recognize this distribution, guys? This is the beta distribution we talked about in the class. Yeah? Yeah. So the first thing you must do, guys, is to write down the likelihood function, right? So here you have two parameters. If you look at the notes, you will see that the density function I must put the product sign here, guys. Alright, so this is the product of the density function of the beta distribution, which is this one. Yeah, if you look at the lecture notes, you will see this formula, guys. Yeah. Now, if you take the product of this, you have right. So this is the simplified form of the likelihood. Once again, please, I mentioned this enough times already. Please make sure you know how to simplify likelihoods, because if you mess this up, then everything else is messed up too, right? If you mess this up, then you will get very low mark. All right. The next step, all right, is to take the log likelihood. So the log of this log of this guy. So this will be equal to come on. This will be this. Now plus the log of that is going to be a1 minus 1, the sum
right? This is the log of the likelihood. Remember, when you take the log of remember the property that the log of a product is the sum of the logs. That's what I have used here. So when you take the log of this, it becomes the sum of the logs. The same thing here, right? Right? Once again, if you look at the course website, it gives you certain properties that there's a link to the elementary mathematics. You should go there, you will see a list of properties. You can remember to simplify likelihoods, right? All right, the next thing is because we have two parameters, we need to find the partial derivatives. All right, first with respect to a1. So if you take the partial derivative with respect to a1, you get right, this is the partial derivative with respect to a1, right? Now you can simplify this further by writing this as yeah. You see what I've done here. I have written this in this form. Now this is, I'm sure all of you know, guys, what I have done is known as the chain rule, which I'm sure you know what means chain rule, right? Now let me ask you, what is this equal to? The partial derivative of a1 plus a2 with respect to a1 is equal to it's equal to 1, right? Yes. Okay, so what you have guys is equal to what you have is equal to I'm going to use a new notation here. Right, the notation psi. Let me put this in a box, guys, so you can see this. The notation psi is defined as this is known as the this is known as the digamma function. So I have used this special function to represent this by this and this by this, right? Okay. So this is a popular function, a digamma function, right? And similarly, I'm not going to do the similarly. The partial derivative of the log likelihood with respect to a2, I'm not going to repeat the details one more time. I will just write down the final answer. You can check this if you like when you have time. right? The partial derivative with respect to A2, guys, can be shown to be equal to this, right? So this is the partial derivative with respect to A2, and this is the partial derivative with respect to A1. So the MLEs of A1 and A2 are the solutions of this equal to 0, and so this is what I have set. I have set the partial derivative with respect to A1 to 0, and also the partial derivative with respect to A2 to 0. So these the solutions of these two equations. So this is the equation obtained by setting the partial derivative with respect to A1 to 0, and this is the equation obtained by setting the partial derivative with respect to A2 to 0. So the solutions of these two equations give the ML of A1 and A2. Obviously you can't solve them analytically, so once again you have to use some software, like for example the R software. You can use some software to find the solutions of the two equations. Okay. Is that clear, guys, or not? You guys okay? Yeah? Thank you. So that's example 42 from the booklet. Example 6. Any other examples or questions from the past papers you'd like me to do? There's one more example class today from 4 to 5, so you can come to that too if you like, if you have more questions. Or you can think of more questions in the meantime. You guys okay? You okay? Yes. Yeah, you can. Yes. Same, yeah. It's the same. For the exam, I think if you look at the formula sheet, guys, you will need to know the gamma function. You also need to know the beta function and the properties of the gamma function. And you already look. I'm sure you also have looked at the formula sheet, right? There are a list of properties. I think it gives you the list. It gives you the list of properties you need to know for the exam. So any other formula that is not in the list will either be given to you in the paper, exam paper I mean, or you'll be asked to derive them. Okay. Right, so yeah. Alright guys, I'll see you late. If you're coming later, please think of more questions, okay? So I'll see you later at 4 o'clock if you're coming. Also for next week, please bring more questions, guys, for the classes next week. Please think of more questions you can ask me. Okay? Thank you. Thank you. You all got your test papers back. I still have some test papers in my bag. Carrying this around to all the places I'm going. You haven't signed, you mean?
I haven't collected one.
Do your test, you mean?
Yeah.
Okay. What's your surname?
Fatima.
Is it A?
Fatima, no.
F, okay. Well, I'm carrying this around to all the places and nobody's collecting those. Okay, I'm trying to find out. Okay. This is G. This one.
No, Fatima.
Let me pull this off just a minute. Sorry. Z here. Z is here. Okay, here. Should be here. Almost box. Almost this one. Yeah, you got very well there. If you have any questions, just feel free to come and see me. Okay.